I'm going to recap integer addition with you all, a number addition, adding a positive or either adding a negative. I'm going to start off with negative 7 plus 9. I'm going to use a model, and we're going to work our way from the model, and we're going to go into the already book today, okay? All right, so let's start off with negative 7 plus 9. I'm going to start off with the chips first. So, of course, we know that 7 negatives. 1, 2, 3, 4, 5, 6, 7, and that's going to be 9 positives. And I'm going to quickly go through this because we already know it. So I can make a total of, as you can see, 7 zero pairs, and I'm left with positive 2. But keep in mind that these chips were different. One was positive, a set of positives, and the other was a set of negatives. The math part was just to take 9 and subtract 7. And as you can see, you have more positives than negatives. So subtract and see what you have more of. Okay. If you use a number line, start at 0, go to negative 7. So this goes to the left. And then to add 9, it goes 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. It puts you at positive 2. Let me make that a little better. Put you at positive 2. So that was 9 to the right. But if you notice, this is left and that's right, and these are also different. The math part is just to subtract. And you're more to the right than you are to the left. You were 9 to the right. So on the right side of 0, that you find nothing but positives. So you can look at it that way. Right on number 2, I see that I have 4 negatives. Sorry, guys. I see that I have 4 negatives, and then I have 5 more negatives. So you don't have any 0 pairs because all your chips are the same color. So 4 negatives and 5 negatives make 9 negatives. Basically, these chips are the same. So the math part, we could just add 4 plus 5 gives us 9. And of course, they're all negative, so you would get a negative. If you use a number line to model this, negative 4 goes to the left. So you would start at 0 and go to the left 4 to get to negative 4. And then to add negatives, to add more negatives, you would just go to the right. So I'm going to go to the right. 1, 2, 3, 4, 5. And it puts me at negative 9. But we're still going left 5 more. Left 4 and left 5. So if you're left 4 is 0 and you're left 5, you're just left even more, which means you're left 9. So again, if they are the same, basically you add. And if some on the left is negative, or if they're all negatives, is negative, depending on what model you're using. On number 3, I have 3 positives. And then I have 10 negatives. I will be left with 7 negatives. Basically, these are different. Those are positives, those are negatives. So I can say since they're different, the math part would just be to subtract. Again, I'm just reviewing what we've already learned. And you got more negatives than positives. So the answer is negative. Now, if you use a number line, you would go to the right 3. And then add a negative, you would just go to the left 10. But they're going in different directions. That's 3, 4, 5, 6, 7, 8, 9, 10. It puts us at negative 7. Again, they're going in different directions. Just like these were different chips. Those are positives, those are negatives. So when they're different, the math part is just to subtract and see what you have more of. You got more negatives, it's negative. You got more positives, it's positive. Or if you're looking at a number line, you can say if it's more to the right, it's positive, more to the left, it's negative. In this particular case, it was more to the left. It was 10 to the left. So it's going to be negative. If you look at number 4, of course, we all know what 3 plus 5 is. I'm going to model it. Those are my 3 positives and my 5 positives. I don't have any 0 pairs, so I can't cancel anything. So I just end up with 8 positives. The math part on this is just to add. These are the same, so we're going to add. 3 plus 5 equals 8. Now, I end up with positives on this because I have nothing but positives. But on this other one where I added, but I ended up with negatives because I had nothing but negatives. On the number line, you can start at 0 and go to the right 3. To add 5, you would continue to go to the right. So that's right and right. That's the same direction. So again, just add. But go to the right 5. That puts us at 8. Right 3, right 5 puts us at 8. So I'm not going to play those videos right now. I'll go back to those. The main thing I want to look at is this part right in here. It says if the chips are the same color or on a number line, the arrows go in the same direction. Keyword same. Blank the numbers. Well, when they were the same, we added the numbers. Same, we added the numbers. So if they go in the same direction, we're going to add the numbers. If they're the same, we're going to add the numbers. And then as far as the sign, well, these were all positives. So our answer is positive. But here, these were all negative. So our answer was negative. So if you add all positives, you get a positive. If you add all negatives, you get a negative. So basically, when you add, you just keep the sign. If they're the same, you add and keep the sign. Okay, if they're different, or on a number line, the arrows go in different directions, keyword different, then we should know what to do. So go back and look. When they were different, what did we do? When they were different, we subtracted. Go here. These were different. We subtracted. That was the math part. And we've already talked about this, so we should know this. So if they're different, we need to subtract the numbers and blank the sign of the blank group. Okay, what does that mean? Okay, so when they were different, this particular was negative. Okay, so, and if you look, you have more negatives than positives. So your answer was negative. Okay, you got 10 negatives and 3 positives. The answer was negative. Now go back and look at number 1. On number 1, you had more positives than negatives, so your answer was positive. So I'm going to go back. It's all about what you have more of. So after you subtract, I want you to take the sign of the larger group. So if you got a larger group of negatives when you subtract, the leftover is going to be negative. In other words, the answer is going to be negative. If you got a larger group of positives when you subtract, the leftover is going to be positive. So you just take the sign of the larger group. All right, I'll get to those videos later. And so let's take a look at the next 5. It says, without using models, find each sum. So I know that I have negatives and positives, or you can say this is to the left and plus a positive is to the right. Well, I know those are different. So when they're different, we should subtract, okay? So when you subtract, you put the larger group first. 83 is the larger group. I'm going to have to regroup because I can't start off with a 3. So that becomes a 7 and that becomes a 13. 13 minus 8 is 5 and 7 minus 2 is also 5. Now I have more positives than negatives, or you can say it's more to the right than it is to the left. And the numbers that are left on the right side of 0 are positives. All right, let's take a look at number 2. And you need to be taking notes, guys. So go ahead and pause the video and make sure you're writing these down. Get everything written down before I start going over it, okay? So pause the video if you need to and write the problems down. All right, so on number 2, this goes to the left. This goes to the right. Plus positive goes to the right. Those are different. Or you can say you have negatives and positives, but you do. So we know we're going to subtract. Put your larger group on top. My largest group this time is a group of negatives. And subtract 7 minus 3, 4 I can do is 3. 9 minus 5 is 4. But in this particular case, it's more to the left. Or you can say it's more negatives than positives. So your answer is negative 43. All right, I'm going to give you something I call SADS. This stands for same direction or same group, add, or different direction or different group, subtract. And that may help you remember when to add and when to subtract. SADS, same group, add, or same direction, add, or different group, subtract, or you can say different direction, subtract. SADS, same, add, different, subtract. Okay, let's take a look at number 3 and make sure you write these down. Pause the video and go ahead and write down 3 and 4 and leave some space. All right, I'm just going to establish direction with a number line. This is to the left, or you can say that's negative. When you add negatives, that's to the left. And you add positives, it's to the right. So I'm going to add up all my negatives or the ones that go to the left. They're the same thing. I'm going to go ahead and add them. Remember, SAD says same direction, add, same add, and then different, subtract. Okay. Same, add, different, subtract. So those are the same. I'm just going to add them up. 32 added to negative 32 added to negative 49. 2 plus 9 is 11. Regroup there, carry. That's going to give us 81, but it's negative. And then I have 17 to the right. So negative 81 plus 17. And so what I'm going to do, since those are different, I'm going to subtract. So I'm going to take 81 and subtract 17. I'm going to have to regroup because I cannot start off with 1 and take away 7. So that becomes a 7. That becomes an 11. So it's 4 and 6. But it's more negatives than positives. Or I could say it's more to the left than it is to the right. So the answer is negative 64. And that plus 17 came from right here, guys. 17 to the right. Okay? So let's take a look at number 4. Matter of fact, you can pause the video and try this if you want to. This is going to be 76 to the right. When you add negative 34, it's to the left. When you add negative 14, it's also to the left. When you add a positive 15, it's to the right. So I'm going to take my negatives, or the ones that go left, and I'm going to add them. So let's look at that. So the ones that go left, it'll be 34 to the left. Thank you. That's 34 to the left and 14 to the right. So that's negative 48 to the left. And then I'm going to take the ones that are positives, or the ones that go to the right, and I'm going to add those. So 76 to the right and 15 to the right. 6 plus 5 is 11. Regroup that. That's going to be 9. It's 91 to the right. But what do you do with these two? These two here when they go in different directions. Well, when they go in different directions, you're going to subtract. So I'm going to take my negatives and positives and subtract. So we have negatives and positives. You can make some zero pairs to figure out the leftover. So you're going to subtract. So I'm going to take 91 and subtract 48. Well, I can't take 1 minus 8, so I'll borrow. And that becomes an 11. 11 minus 8 is 3. 8 minus 4 is 4. And just think about it. It's more positives than negatives. So your final answer is going to be positive 43. And you don't have to put that positive there. I just do it. Or you can say it's more to the right than it is to the left. All right, you pause the video and try number 5. Okay, let's take a look at it. 10, negative 10, that's negative, or you can say it goes to the left. Plus positive goes to the right. Plus negative goes to the left. Plus positive goes to the right. Plus negative goes to the left. All right, so I'm going to take all my negatives, or the ones that go left, and add them. And then I'm going to take all my positives, or the ones that go right, and add them. And then in the end, I can subtract what I got, or what I have. So all those to the left were negatives. Negative 10 plus negative 29 plus negative 49. Let's add them up and see what we have. 9 plus 9 is 18. Carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 4 is 8. That gives me negative 88. Okay, let me add up all this that goes to the right. That'll be 49 and 65, just 2. 9 plus 5 is 14. Carry the 1. To a different color. 1 plus 4 is 5, and 5 plus 6 is 11. So it's 88 to the left and 114 to the right. But when they go in different directions, or when you have negatives and you have positives, you can make some zero pairs. So you just subtract to see what you got left over. It's going to take my 114 and I'm going to subtract 88. I'm going to have to regroup. This becomes a 0, so that can become a 14. Or can become a 14. And 14 minus 8 is 6. I can't start off with 0 minus 8, so this becomes a 0, so that becomes a 10. 10 minus 8 is 2. And you got more positives than the negatives, or you can say it's more to the right than it is to the left. So this is positive 26, and you're done. But there was a shorter way, and I know some of you saw it, and you're like, I don't know why Miss Blue didn't do that in the beginning. This is what you could have done, guys. You could have gotten rid of positive 49 and negative 49. And the question is why. So I'm going to show you again. You could have gotten rid of these two. Positive 49 and negative 49. Well, they're opposites. And when you add opposites, 49 plus negative 49 makes a zero pair. You could have just canceled them out. And you could have went with negative 10 and negative 29 makes negative 39. Added to 65. And you just could have subtracted 65 minus 39. It becomes 5, 15, and becomes a 15. And got into 26 that way. Okay. But, no, that's totally up to you. Just another way of doing it. But I probably would have looked at those zero pairs, meant those are additive inverses or opposites, and know that when you add them, they make 0. So you could just cancel it out. All right, now I'm going to show you these 2 videos. And we're going to talk about a few word problems after the few videos, okay?
There's a place down yonder where 3 streams converge into one. It's where I watched the Mandalorian get himself into it.
The integers are positive and negative whole numbers. Here's a slightly more technical definition. So the integers are the whole numbers, 0, 1, 2, 3, etc., and their opposites, as in -1, -2, -3, etc. We can visualize integers on a number line like this. 0 is a whole number, so it's also an integer. 1 is a whole number, so it's also an integer. And the opposite of 1 is -1, so -1 is also an integer. 2 is a whole number, it's an integer. Its opposite, -2, is also an integer. This can be extended forever. 5 and -5 are both integers. 5 billion and -5 billion are both integers. However, the numbers between the whole numbers and their opposites are not integers. So, for example, 1.5, halfway between 1 and 2, is not an integer. Nor are any fractions or mixed numbers anything that occurs between positive whole numbers or between their opposites is not an integer. Integers are positive and negative whole numbers. Thank you.
So that's going to be on a page that I'm going to assign for homework. It's going to talk about what integers are, and I didn't want you to be confused when you saw it. It's going to be on one of those green pages I'm going to assign in the I Ready Math book. So it's going to ask what integers are, and I'm going to need you to make sure you write this in your notes. Let's go ahead and write this down. And again, make sure you're taking notes. Integers are whole numbers and their opposites, guys. That's what we call them. They're just regular numbers. They're like positive and negative numbers. The whole numbers are things like 0, 1, 2, 3, 4, and so forth. Those ellipses mean so on. Okay, but those are the whole numbers, okay? The opposites just means you just change the sign, but 0 doesn't have an opposite. 0 is the only neutral number. It's neither negative nor positive. But 1 does. The opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. I don't like writing those like that. Let's rewrite this. You have and so on, because your negative numbers keep going. Suppose I have -3, -2, because that's the way the negative number is going to number line. So I'm going to order it that way. These are all the opposites right here. And then if I were to do this, those are all the whole numbers. These are all the whole numbers. And these are all their opposites. Just the negative counterparts. Okay, that's all that means. So on that green page I assigned, you're going to need to put integers or whole numbers and their opposites. And these are some examples. These are some of the opposites, and these are the whole numbers. Whole numbers and then some of the opposites. Now, you will not find decimals or fractions. Okay, there are no decimals. You want to put this down. Put this down as a little note. There are no decimals or fractions in the whole number set, in the integer set. Okay, you won't find any decimals or fractions. It's just whole numbers and the opposite, and that's it. All right, so you'll be able to fill out that green page, and you have some examples. I gave you some examples of what they look like. Like if I had -10, well, -10 is the opposite of +10, which is a whole number, so I'm good. Or 100, or 1 million, or -1 million. All those are examples of integers, guys. because it either is a whole number or the opposite of a whole number, like its negative counterpart. That's all. All right, let me show you another one. This one might sign me out, but I have to sign back in. It probably is going to sign me out. We'll try it.
Isn't it interesting how much the temperature can vary across the world on any given day? For example, it could be 82 degrees, show up often in the real world,
Sorry.
and are used in areas like banking, as in credit, which is anything that is added to the account, and
I'll have to
debit,
replay
which is
it.
anything taken from an account. It is also shown in things like electricity, elevation, which, remember, is the distance above or below sea level, and temperature. Isn't it interesting how much the temperature can vary across the world on any given day? For example, it could be 82 degrees above zero in Hawaii, and at the same time, 5 degrees below zero in Alaska. Considering how much the temperature can vary depending on where you are in the world, it's good that we have different types of numbers available to represent them. For example, the temperature of 82 degrees above zero is a positive number, and we write it as 82. Whereas the temperature of 5 degrees below zero is a negative number, and we write it as minus 5. Technically speaking, we have the following. A positive number is a number that's greater than zero. It falls above zero on a vertical number line, or to the right of zero on a horizontal number line. A negative number is a number that's less than zero. It falls below zero on a vertical number line, or to the left of zero on a horizontal number line. Notice that if we think of our thermometers as vertical number lines, 82 falls above zero, and minus 5 falls below zero, as we would expect from the definition of positive and negative numbers. Well, that's pretty neat, and guess what? It doesn't end there. Let's explore some other instances of positive and negative numbers in the real world. Another interesting area in which positive and negative numbers show up is elevation. The elevation of a location is its distance above or below sea level. If we consider the fact that sea level has an elevation of zero, you can probably guess which type of number corresponds to above sea level and which type of number corresponds to below sea level. Since positive numbers lie above zero, they must correspond to elevations that are above sea level. And since negative numbers lie below zero, they must correspond to elevations that are below sea level. Consider the city of New Orleans, Louisiana. New Orleans often experiences flooding because some areas of New Orleans actually lie below sea level. For instance, one of the lowest elevations in New Orleans is at 6.5 feet below sea level. So we say the elevation is minus 6.5 feet, a negative number. On the other hand, one of the highest elevations in New Orleans is at 23 feet above sea level. So we say the elevation is 23 feet, a positive number. Here's another example. You're likely watching this on a computer or a smartphone. Your device takes electricity to work, and electricity has to do with the charges of 3 particles: electrons, neutrons, and protons. Each of these particles contain charges that allow electricity to work as it does. Electrons contain a negative charge and are therefore associated with negative numbers. Protons contain a positive charge and are therefore associated with positive numbers. Neutrons are neutral, meaning they don't have a positive or a negative charge, so you can think of these as having a charge of 0. Wow, positive and negative numbers seem to show up everywhere around us. Let's take a look at an application of these numbers. Suppose Sarah used her bank card while she ran the following errands today. Number 1, went grocery shopping and spent $41. Number 2, went to the bank and deposited $320. Number 3, met up with a friend for lunch and spent $17. Number 4, sent in a payment for her electricity bill of $84. Number 5, received an electronic refund on her bank card of $35. At the end of the day, she sits down to balance her checkbook. Her balance in the account before running her errands today was $770. Let's use positive and negative numbers to help her balance her checkbook. In banking terms, anything that is added to the account is called a credit, and anything that is taken from the account is called a debit. Since credits occur when you add to the account, they are associated with and recorded as positive numbers. And since debits occur when you subtract from the account, they are associated with and recorded as negative numbers. Based on Sarah's list of errands, which errands do you think are credits and which do you think are debits? Well, grocery shopping, lunch, and the electricity payment all take away from the checking account, so these would be debits, and we would record them as minus 41, minus 17, and minus 84 respectively. The deposit and the refund add to the checking account, so these would be credits, and we record them as 320 and 35 respectively. Therefore, to balance Sarah's checkbook, we add the credits and subtract the debits from the previous balance. Ta-da! We can see that Sarah's new balance is $983. Not only do positive and negative numbers show up everywhere around us, but they also prove to be quite useful in real-world applications. Let's briefly review what we've learned. A positive number is a number that's greater than 0, and it falls above 0 on a vertical number line, or
All right, that's all I'm going to show you from that right there. All right, but my main thing is I need you to know what an integer is. It's a whole number or a whole number's opposite. And I need you to understand that you're going to see integers all in real life. You're going to see them with money. You're going to see them while playing games, whether they're football games, basketball games, gaining yards, losing yards, gaining points, losing points. It could be, just video games. You would see them in temperature, above freezing, below freezing, above 0, below 0. You will see them everywhere. You're going to see numbers or integers everywhere, guys. All right, so let's just take a look at some real life application problems that involve integers, which are just positive and negative numbers. So let's take a look at it's not number. We're going to take a look at this problem. So the temperature at a mountain weather station is -3 degrees Fahrenheit at sunrise. Then the temperature rises 5 degrees. So what is the new temperature? So I'm going to model this out even before I write it, because I like for you all to write these expressions. We're going to practice doing that too. I'm not going to ask what is the new temperature. Not only am I going to ask that, I'm going to ask you to write the expression too. So I'm going to write the expression first. You make sure you pause the video and copy this down. Okay, so just because I want to show you on a number line or model it, so I want you to understand what I'm doing. And then we can write the expression easily, guys. So it says it's -3 degrees at sunrise. So I'm going to start at 0 and go to -3. And then it rises 5. Well, to rise 5 means that's plus 5. It goes up. 1, 2, 3, 4, 5. So the new temp would be at 2. And I'm going to go ahead and put this was to -3 and this was plus 5. So no, the new temperature is 2 degrees Fahrenheit. But the expression, though, would have been -3, which is where I know I started at 0, but I went to -3, plus 5. So plus positive. That's the expression. And I'm going to write the new temperature. Is 2 degrees Fahrenheit. And that's all. But I need you to, my main thing is, can we write this, guys? -3 plus 5. Now, I know I just showed you that video where I talked about debits and credits and how debit was associated with a negative and a credit was associated with a positive. Or you saw the word deposit. Deposit was positive, or above was positive, below was negative. Those are words that are associated with positive and negative numbers. Well, the word rise is associated with a positive, so you know you're adding a positive because of the word rise. Now, if it said that it dropped, you wouldn't be adding a negative. You wouldn't be adding a positive. You would be adding a negative, okay? So you look for keywords to help you decide whether you add a positive number or you add a negative number, okay? All right, let's take a look at this one. It says when Ria goes to school, the temperature is negative 5 degrees Fahrenheit. During the school day, the temperature rises, keyword, helps me to see that I'm going to add a positive. Rises 15 degrees Fahrenheit. What is the temperature when Ria leaves school? Show your work. So what I want first is for you to write the expression. You make sure you pause the video and write this down because I don't have these notes printed for you. So when I say write the expression first, tell me where it starts. Well, when she goes to school, it's negative 5 degrees. I'm going to write negative 5. Plus, now it's either plus a positive number or plus a negative number. But a rise indicates that you're going to be adding a positive number. So go with plus positive 15. And then just apply your, what you learn about adding integers to figure out what this new temperature will be, or the temperature is going to be when she leaves school. So this is to the left, or we can say it's negative. That's to the right, and we could say it's positive. They go in different directions, or we can say they're different signs. You got negatives and positives. You're going to end up with a positive 10 degree Fahrenheit. So I'm going to put the temperature when she leaves school is 10 degrees Fahrenheit. And yes, I want you to write the answer in sentence form. And that's all you have to do. But make sure you're pausing the video, guys. You can't copy all of this down and listen to me while I'm working, okay? You got to pause the video. Listen to me, pause the video, write something down. Listen to me until you get to a certain point, pause the video, write it down. All right. Or you can just pause the video on this and write the whole thing down. Then watch me, okay, guys? Normally, the freezing point for water is 32 degrees Fahrenheit. But then a city treats its streets before a snowstorm because you don't want ice on your roads. So they treat it. On treated streets, the freezing point for water is changed to negative 38 degrees Fahrenheit. So they treat it so that the freezing point for water has to be much, much colder than 32 degrees Fahrenheit, okay? It's got to be negative 38 degrees Fahrenheit. It says, it's changed by negative 38 degrees Fahrenheit. In other words, when it's changed by negative 38 degrees Fahrenheit, it simply means that it drops 38 degrees, okay, Fahrenheit. It changes by that much, so it means it drops that much, okay? The reason why I know it drops is because that 38 is negative, so I know it drops or goes down. It says, what's the new freezing point for water on the treated streets? So I'm going to have you write an expression, but before that, I'm going to model this. And no, I will not be able to count by ones. I'm not doing that. Zero, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. I'm having to go up here, guys. So as you can see, I'm counting by twos. -2, -4, -6, -8, -10, -12. We're going to pretend like they're all evenly spaced, although we see that they're not. Okay, so I'm counting by twos. So I'm going to say if it starts off at 32 degrees Fahrenheit, I'm going to go to 32. There's the 32. That's normally the freezing point for water. So like if you have ice on the road, it occurs when it's 32 degrees Fahrenheit. The water that was on the road has frozen, or the dew or whatever. It's frozen. Now, a city treats its street before a snowstorm. So on the treated streets, the freezing point for water is changed by -38 degrees Fahrenheit. In other words, it drops 38 degrees Fahrenheit. So if it drops 38, let's see, or if it's changed by that 38 degrees or drop of 38, let's see what it happens. So let's go a drop of 38, guys. So it's a drop of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. A drop of 32 we would expect will put us back at 0, but this is not a drop of 32. It is a drop of 38. So let's keep going. Drop of 32, 34, 36, 38. Okay. So the new freezing point for water on the treated streets would be -6. So instead of water freezing on the streets at 32 degrees Fahrenheit, once they treat the streets with the whatever substance they put on it, water will not freeze at -6 degrees Fahrenheit. So it's going to take a much colder temperature in order for the water to freeze on the streets. Okay. But the expression you could write is where it starts, which is 32. Plus, because it's dropping 38, guys, or it's changing by -38, I get to add -38 to it. So that's the expression. But I know this goes to the right, and you didn't have to draw the model. I just chose to do that to help you to see what a change of 38 will look like. From 32, a change of 38 will put you, a drop of 38 will put you at -6. And this would be -6 degrees Fahrenheit is the new freezing point. Let me write that a little better. So in the other two cases, I added a positive. Like in this case, because it was a rise of 15, I added a positive 15. And this was a rise of 5, so I added a positive 5. But in this particular case, -38 indicates a drop of 38. So you add a -38, guys. And it's just that simple, and see where you end up at. All right. What I want you to do now is I want you to complete pages 156 through 158. If you don't finish, it's for homework. You're going to type your answers in the document using Kami, then submit. No, you cannot give this to me on notebook paper when I get back. Okay, I'm not checking for that. I need to be able to check before class tomorrow, okay? So yes, I'm going to need you to submit this before 11:59 tonight. Preferably try to submit it early, like before 7 o'clock, so I can check it. I'm not going to count it wrong or as a 0 if you don't submit it before 7 o'clock tonight. But preferably I would prefer that so I can go to bed. But I will be checking these when I get up in the morning, nevertheless, before class starts. So make sure you submit this on Kami. Don't say I'm going to give my answers to Miss Blue or let her check the book work when she gets back. No, I need to see it. So I have uploaded these pages on Google Classroom. You are to work on them now. All right, thanks, guys.